Our lesson today is to be able to find the mean absolute deviation of a set of data. First vocabulary word is statistics. That is the science of collecting, organizing, and analyzing and interpreting data. Measures of variability are values that describe how data is spread out. Our range and interquartile range, which we've already studied, are measures of variability. The mean absolute deviation is another measure of variability. Mean absolute deviation is defined as the average amount that the data values vary from the mean. Now, why do we want to learn this? Well, if we look at this example, we're looking at the yield of some tomato plants. One tomato plant, or the first tomato plant, yielded 17 tomatoes. The second tomato plant yielded 22 tomatoes. The third tomato plant yielded 16 tomatoes, and so on. You can describe a data set by studying its center, spread, and overall shape. A value that describes how data is centered is called a measure of center. The mean, median, and mode are your measures of center. A value that describes how data is spread out, such as the range, is called your measure of variability. One measure of variability is the mean absolute deviation. That is the average amount that data varies from the mean. Well, in order to find the mean absolute deviation, we're going to take a look at that example of the tomato yields. Step one is to find the mean number of tomatoes over that 10-day period, and we record the mean in the table here. So we look at that example that we started with of the tomatoes, and we find the mean number of tomatoes that the plants yielded, and that mean is 24. That's step one. Step two is to find the distance between the number of tomatoes on each plant and the mean. We will always write these distances as a positive number. So if the mean was 24 and plant number 1 yielded 17 tomatoes, that mean of 24 is 7 away, or that number of tomatoes, 17, is 7 away from that mean of 24. Even though it's less than 24, we still write that distance of 7 as a positive number. The second tomato plant yielded 22 tomatoes. 22 is 2 away from the mean of 24. So that second tomato plant is 2 away from the mean of 24. The third tomato plant yielded 16 tomatoes. 16 tomatoes is 8 away from the mean of 24 tomatoes. The fourth tomato plant yielded 45, right? And that is much greater than the mean of 24. That is 21 away. But notice, we have to do that for each tomato plant, and we have to write that distance as a positive number. Step 3 then is pretty simple. We need to calculate the mean of all those distances in the bottom row. We need to calculate the mean distance each plant is from the mean. So we add those distances up, we divide by the number of plants, which is 10, and we get a mean absolute deviation of 6. All right? Here's another example. Finding the mean absolute deviation from a line plot. You record the number of raisins in 8 scoops of cereal. Find and interpret the mean absolute deviation of the data. Right? Here are our number of raisins in scoops. So we have 1, we have 3 2s, right? 1, 2, 3. We have 3 4s, 1, 2, 3, and we have 1 5. We find the mean of that data, which is 3. Then we have to see, well, how far is each item from the mean? Well, 1 raisin would be 2 from that mean of 3. Each of these 2s would be 1 from the mean of 3. Each of these 4s is 1 from the mean of 3, and 5 would be 2 from the mean of 3. Once again, we find the mean of these distances. So I have to add these distances together and divide by 8, and we get a mean absolute deviation of 1.25. All right, let's try it with our own data here. All right, we want the mean absolute deviation of this set of data here. So first we need to find the mean. So we have to find our sum. So we have to take the 5, add the 8, plus the 8, plus the 10, plus the 13, plus the 14, plus 16, plus 22. 1, 2, 3, 4, 5, 6, 7, 8 items. 1, 2, 3, 4, 5, 6, 7, 8 items. We find the sum of that data. So to find the sum, we add 5 plus 8 plus 8 plus 10 plus 13 plus 14 plus 16 plus 22. We get a total of 96. Right? So the sum is 96. We have to divide that sum of 96 by 8. And when we divide that sum of 96 by 8, we get a mean of 12. Right? So the mean equals 12. And now we need the distance from the mean. The distance from the mean. So 5 is how far from 12? Well, that's 7. 8 is how far from 12? That's 4. The other 8 is 4 from 12. 10 is how far from 12? Well, that's 2. 13 is how far from 12? That's 1. 14 is 2 from 12. 16 is 4 from 12. And 22 is how far from 12? That's 10. We have to find the mean of these distances. So we have to add 7 plus 4 plus 4 plus 2 plus 1 plus 2 plus 4 plus 10. We get a sum of 30. We have to divide that, or I'm sorry, we get a sum of 34. Sum is 34. And we're going to have to divide that sum by 8. And when we divide that by 8, we get a mean absolute deviation of 4.25. That is our mean absolute deviation. All right, and we identify that using the initials MAD. All right. Now let's take a look at a real live application of the mean absolute deviation. All right, and you guys know that my son plays baseball and I've managed baseball for a long time, so this is kind of a neat example. It says the following: the smartphones shows the number of runs allowed by 2 pitchers in their last 10 games. First, they want us to find the mean, the median, and the mode, or the mean, median, and the mean absolute deviation of the number of runs allowed for each pitcher. All right. Well, if we look at Mendoza, we have his data here. Mendoza's got 3 games where he gave up 0 runs, game where he gave up 2, a couple games he gave up 4 runs, and so on. The mean of that information is 3.5. The median is 4. Right? And his mean absolute deviation is 2.4. Right? Let's do the same for the next person here. All right, we want to do the same thing for Rodriguez. So let's start by finding the mean. So we have to add each of his data items. So we start with 0, and then we add 2, and then add another 2, and then we add 3, and then we add 4, 4, and 4 again, 5 and 5, and then we add a 6. And we get a total of 35. We want to divide that by 10, right? And we get a mean of 3.5, right? Which is the same mean that we had for the other person up here, Mendoza. So both Mendoza and Rodriguez have a mean of 3.5. So if we're looking at a measure of center, mean is going to be 3.5. If we're looking at the mean, right, the mean is going to be what? The 2 middle numbers here, right? Because we have 4 less than that, 4 greater than that. So we also have a median, right? A median of 4 for Rodriguez. So if we're looking at our measures of center, the mean is the same for each pitcher. The median is the same for each pitcher. So just judging using measures of center, looks like both pitchers, right, are the same. We get the same data for both pitchers. But let's take a look at if we use a measure of variability. Let's take a look at our mean absolute deviation. So I want to see how far each one of these varies from the mean. Our mean is 3.5, so 0 varies 3.5 from the mean. 2 is going to be what? 1.5 and 1.5. 3 is going to be 0.5 4 is going to be, what, 0.5? And we have 3 of those. 5 is going to be what? 1.5? And then 6 is going to be what? 2.5. Okay? Now, let's find our mean absolute deviation. To find the mean absolute, our MAD, our mean absolute deviation, let's erase that because that was sloppy. Right? To find our mean absolute deviation, we have to first find the sum of those numbers. So we take 3.5, we have to add 1.5, 1.5, plus 0.5, plus 0.5, plus 0.5, plus 0.5, plus 1.5, plus 1.5, and then plus the 2.5. Press equals. We get a total of 14. Right? So our total is 14, and we have to divide that 14 by 10. So we get a 14 over 10, which is going to be 1.4 for our mean absolute deviation. Now what does that tell us? Well, that tells us that because we have much less variability here, our data varies much less with Rodriguez than it does for Mendoza, because Mendoza has a mean absolute deviation of 2.4, which means that on average each one of his baseball outings varies 2.4 from the mean, which means he's less consistent. It means Rodriguez is a more consistent pitcher, meaning he's going to be closer to what his average is each and every outing. Means he's not going to give up a ton of runs, right? He's not going to give up in 8 runs, right? And he only gave up 6 once, but he may not have as many 0-run outings either, right? He's only got 1 0-run outing, but what is that? Mendoza has 3. All right? And that's essentially it for our mean absolute deviation, right? That's 2 calculations that we had there for us, and that's something that I think you guys would be able to practice. All right? And hopefully that was helpful, and we'll see you soon.